During a job interview for a Spring developer position, you may encounter questions related to the Spring JPA projections. Are you ready? Let's check what you know. Our first question deals with what projections are. A projection is a technique used to fetch a subset of data from an entity instead of retrieving the entire entity. Projections can optimize query performance and reduce memory usage, especially when dealing with large datasets or complex data structures. In Java applications, projections can be implemented using various frameworks such as JPA Criteria API, Hibernate Query Language, HQL, or Java Persistence Query Language, JPQL, or Native SQL. By applying projections, developers can minimize the amount of data transferred from the database to the application, which can significantly improve performance. Furthermore, projections can be used to map the retrieved data to custom data transfer objects, DTOs, or interfaces, simplifying the application's data processing and management tasks. Using projections strategically in your Java applications can lead to cleaner code, faster response times, and a more efficient use of system resources. How do you implement projections using JPA Criteria API? To implement dynamic projections using JPA Criteria API, you can create a method that accepts a class parameter representing the projection type. Based on the projection type, you can build the query by selecting the appropriate fields using the query.multiselect method and applying the necessary conditions. Dynamic projections provide flexibility when querying data from your database, as the same method can be used for different projection types, reducing code duplication and maintenance efforts. This approach enables you to tailor the retrieved data to the specific needs of various parts of your application, which can enhance performance and resource utilization. Implementing dynamic projections with JPA Criteria API provides a type-safe, programmatic way to create complex queries, which can result in more maintainable and robust code. What is the difference between using projections and entity graphs for optimizing data retrieval in Java applications? Projections are used to fetch a subset of data from an entity, which can reduce memory usage and improve query performance. Entity graphs, on the other hand, are used to define which related entities should be fetched eagerly or lazily to optimize the retrieval of associated data. Projections are better suited when you need only specific fields, while entity graphs are useful for controlling the fetching strategy of related entities. Both techniques can be employed to enhance the efficiency of data retrieval in Java applications. However, choosing the right approach depends on your specific use case and requirements. By combining projections and entity graphs, you can create powerful, efficient queries that retrieve only the necessary data and reduce the overhead of managing large or complex object graphs. How can you combine projections with advanced query features such as pagination, filtering, and sorting in a Java application using Spring Data JPA? You can use Spring Data JPA to create repository interfaces that extend JPA repository and define methods that include projections along with other query features. For example, you can return a page interface with the desired projection type to achieve pagination and sorting. Spring Data JPA automatically generates the required query based on the method name and provided parameters. By combining projections with pagination, filtering, and sorting, you can build powerful, feature-rich queries that cater to your application's specific requirements. This combination allows you to optimize data retrieval, minimize the amount of data transferred between the application and the database, and provide a better user experience by presenting the data in a more organized and easily digestible manner. How can you perform complex data aggregations and calculations using projections in Java applications? You can combine projections with aggregate functions like count, sum, avg, min, and MAX to perform complex data aggregations and calculations. You can use JPA Criteria API, Hibernate Query Language, HQL/Java Persistence Query Language, JPQL, or native SQL to create these aggregate projections and map the results to custom DTO or interfaces. By using projections in conjunction with aggregate functions, you can perform advanced calculations and data analysis directly within the query, rather than retrieving large data sets and processing them within your application. This approach can significantly improve performance, reduce memory usage, and minimize the complexity of your application's data processing logic. Leveraging projections for complex data aggregations and calculations in your Java applications can lead to more efficient and scalable solutions that can better handle large amounts of data or high levels of concurrent users. So how did you do? If you'd like to learn more about projections, visit our website, which I will link in the description below. Give us a like and subscribe to our channel to get more content like this. Until next time.